The Structure of Scientific Revolution by Thomas S. Kuhn. So first, let's talk about Thomas Kuhn. Who was Thomas Kuhn? Thomas Kuhn is an American philosopher of science, the man who changed the way the world perceived and envisioned science. So, his book, 1962, The Structure of Scientific Revolutions, is regarded as one of the most influential and frequently cited academic books, in which he introduced the term paradigm shifts. So, it is a landmark publication that generated worldwide discussions and debates among scholarly communities. It is also one of the most cited academic books, often referred to by scientific guilds and student communities. He is credited with coining the term paradigm shifts, which today has become an integral part of English and scientific terminology. His impact has been felt in all academic fields, including the field of science, education, theory, and research. His contribution to the philosophy of science has inspired various student bodies and has influenced more than 1 billion readers and researchers at large. So, his works has so far laid the foundation for many aspiring researchers who plan to pursue a study of the philosophy of science in the future. He is credited for the accurate representation of science and for introducing a new method towards approaching this branch of study. So his book, The Structure of Scientific Revolution, have 13 chapters, but for our course reading, we will be talking about the chapter 6, which is Anomalies and the Emergence of Scientific Discoveries, and chapter 13, which is Progress Through Revolutions. For us, in order to understand these two, we need to understand the whole book first. So basically, in the book, there is 4 phases of science that leads to scientific revolution. And it starts with pre-paradigm stage. Attempting to discover the source of the difference led me to recognize the role in scientific research of what I have since called paradigms. So in this stage, we are still developing a paradigm. According to Kuhn, a paradigm is a universal recognized scientific achievements and that for a time provide model problems and solutions to a community of practitioners. So once we are committed to this 13th paradigm, we are under to the normal science stage. Normal science is the activity in which most scientists inevitably spend almost all their time is predicted on the assumption that the scientific community knows what the world is like. So Kuhn relates normal science to a puzzle-solving process. So we already have the puzzle piece or the fixed set of rules and procedures, and we just have to complete the puzzle. However, there will come a time that the puzzle piece just won't fit, and this puzzle piece refers to as an anomaly. So let's move to the next phase, which we call the emergence of an anomaly. So, confronted with anomaly or crisis, scientists takes a different attitude towards existing paradigms, and the nature of their work changes accordingly. So, it tells about the crisis, and in this stage, scientists takes or have a different attitudes toward the existence paradigm. Thus, we will force to think outside the box in order to solve this problem. And this thinking out of the box brings us to the next and last phase, which we call extraordinary science. So, extraordinary science is which the shift or professional commitments occurs are the ones known in this essay as scientific revolutions. They are the tradition-shattering complements to the tradition-bound activity of normal science. Phases of science. It is a gradual historical process leading to a scientific revolution. So first, the pre-paradigm stage. lack of consensus. Here we are trying anything in order to develop a paradigm during a pre-paradigm age. So next, normal science. We use this fixed set of rules and procedures during the normal science stage until we undergo a crisis and we need to think outside the box, which brings about a scientific revolution. And it goes around throughout the course of time. If normal science is so rigid, and if scientific communities are so close-knit, how can a paradigm change take place? So this chapter traces paradigm changes that result from discovery brought about by encounters with anomaly. So this is the chapter 6, the anomalies and the emergence of scientific discoveries. So normal science is a highly cumulative enterprise eminently successful in its aim, the steady extension of the scope and precision of scientific knowledge. So normal science, ito nga yung puzzle-solving activity na sinabi ko kanina, and it describe activity with an existing and accepted paradigm. The activity in which most scientists inevitably spend almost their time is based on the assumption that the scientific community knows what the world is like. So normal science does not aim at novelties of fact or theory, and when successful, finds none. Normal science aim is not towards its ends or toward strictly philosophical ideologies. But according to Kuhn, normal science strives not towards progress, but towards normal and revolutionary stages. So, new and unsuspected phenomena are repeatedly uncovered by scientific research, and radical new theories have again and again been invented by scientists. Fundamental novelties of fact and theory bring about paradigm change. So, how does paradigm change come about? There are two ways. First is by discovery, the novelty of fact, and second, by invention, novelty of theory. But novelty of theory is discussed in greater detail in the following chapter. But for this chapter, we will focusing on this discovery of novelty of fact. So how does paradigm change come about through discoveries? So first, awareness of anomaly where discovery commences. So, discovery begins with the awareness of anomaly. So, ano nga ba yung anomaly? So, ito yung problem. Nabanggit ko kanina na may puzzle piece na pag hindi nag-fit sa isang existence paradigm, dito na nagsisimula yung anomaly. And sinabi pa dito na awareness with the recognition that nature has somehow violated the paradigm induced expectations that govern normal science. It means na sa existing paradigm, the normal science, syempre may expectation na dito yung mga existing theory, facts, or information. Pero once na biglang hindi nag-meet sa expectation under ng existing paradigm na to, dito na nagkakaproblema at ito nga yung tinatawag na anomaly. So next, first nga is awareness of anomaly where discovery commences. So, it continues with a more or less extended exploration of the area of anomaly. And then last, it closes only when the paradigm theory has been adjusted so that anomalous has become the expected. So, parang masasabi lang na na-result nila kapag yung expected nilang result is lumabas na or nangyari na. Kumbaga, if yung puzzle piece is nagpit na sa buong puzzle. So, in this chapter, Kuhn examine three discovery. The discovery of oxygen, the discovery of X-ray, and the discovery of Leyden jar. Yung mga discovery na to, according to Kuhn, hindi raw isolated events or ibang kinds ng stories, kundi extended or continuation stories ng regularly recurrent structure or nung normal science or nung existing paradigm they had by that time. So, factual and theoretical novelty are closely intertwined in scientific discovery, as shown by a famous example, the discovery of oxygen. There are Three different men have a legitimate claim to it, and several other chemists in the early 1770s. They had enriched air in the laboratory vessels without knowing it. So the first claimant to prepare a relatively pure sample of gas was Carl William Scheele or Scheele. So he is the earliest claimant of Swedish apothecary. So his work was not published until after his death, when oxygen discovery had repeatedly been announced elsewhere and thus had no effect upon the historical pattern. So we must ignore his work. The second claimant was Joseph Priestley, the British scientist and divine. So, he collected the gas released by heat red oxide of mercury. In 1774, he identified the gas thus produced as nitrous oxide, and in 1775 as common air with less than its usual quantity of phlogiston. So, phlogiston was a material erroneously supposed to be given up when a substance burned. So the third claimant was Lavoisier, that stated the work that led him to oxygen up after Priestley experiments of 1774, and possibly as the result of a hint from Priestley. Early in 1775, Lavoisier reported that the gas obtained by heating the red oxide of mercury was air itself, ether without alteration, except that it comes out more pure, more respirable. By 1777, Lavoisier had concluded that the gas was of a distinct kind, one of the two main constituents of the atmosphere, a conclusion that Priestley was never able to accept. So this pattern of discovery raises a question. Was it Priestley or Lavoisier who first discovered oxygen? In any case, when was oxygen discovered? So, sinasabing hindi raw importante kung ano man yung tamang tanong o yung sagot dito sa pag-intindi ng science or ng discovery. Yung fact na natanong to, ibig sabihin, ang discovery ay isang proseso na maraming pinagdadaanan, and it just clearly shows the fundamentals rule of the discovery. So clearly, we need a new vocabulary and concepts for analyzing events like the discovery of oxygen. Kasi parang nadidiscover na nila yung air na yon, pero hindi pa nila alam yung concept na may ganito at sa ibang aspect pa sila tumitingin. Kasi nga, hindi nila alam yon, and they didn't know what happened by that time. Concepts for us, we need that to have a better understanding na may ganito palang bagay or ganun pala yung isang bagay. At para rin malinaw at maintindihan natin kung kailan ba ito na-discover. So, though undoubtedly correct, oxygen was discovered misleads by suggesting that discovering something is a single simple act assimilable to our usual concept of seeing. Sinasabing misleading daw yung oxygen discovery kasi parang pumapasok sa isip ng tao na oxygen discover by this time. Gato na discover yung oxygen. Na para bang iisang bagay lang siya. Pero no, because any attempt to date the discovery must inevitably be arbitrary, because discovering a new sort of phenomenon is necessarily a complex event, one which involves recognizing both that something exists and exactly what that something is. It's a process and it takes time. Grant now that the discovery involves an extended, though not necessarily long, process of conceptual assimilation. Can we also say that it involves a change in paradigm? So, in this case, we can say assimilating new information does not always lead to paradigm change. This theory was the keystone for a reformulation of chemistry, so that is usually called the chemical revolution. Meaning, hindi lang basta discovery ng oxygen mismo yung naganap dito. After ma-discover yung air ngayon, nag-lead pa ito sa pagkakaroon ng oxygen theory of combustion. Kaya nag-adjust yung chemical theories or yung paradigm. It stated there that mayroong chemical revolution. So, the discovery of oxygen was not by itself the cause of change in chemical theory. So, long before Lavoisier played any part in the discovery of the new gas, he was convinced both that something was wrong with the Phlogiston theory, kung saan nga sila first nag-focus nun, and that burning bodies absorbed some part of the atmosphere. What the work on oxygen did was not give much additional form and structure to Lavoisier's early sense that something was amiss. It told him a thing he was already prepared to discover, the nature of substance that combustion removes from the atmosphere. So, that advanced awareness of difficulties must be a significant part of what enabled Lavoisier to see in experiments ni Presley. We can see here that the discovery of oxygen has an intimate part of the emergence of new paradigm for chemistry. So, next is the discovery of X-ray. X-ray is a classic case of discovery through accident, a type that occurs more frequently than the impersonal standards of scientific reporting allow us easily to realize. So what happened in here is just like the discovery of oxygen, perception that something had gone wrong was only the prelude to the discovery. After the discovery of X-rays, previously completed work on normal projects would now have to be done again because earlier scientists had failed to recognize and control a relevant variable. So, X-rays, to be sure, open up a new field and thus added to the potential domain of normal science. So, from here, pinapakita na yung essential sense in which the discovery of X-rays is necessity a paradigm change. So, remember, paradigm procedures and applications are necessary to science as paradigm laws and theories, and they have the same effect. As a result, we may also understand how the discovery of X-rays could seem to open a strange new world to many scientists and could thus participate so effectively in the crisis that led to 20th century physics. So, last discovery is the discovery of Leyden jar. Leyden jar belongs to a class that may be described as theory induced. To greater or lesser extent, corresponding to the continuum from the shocking to the anticipated result, there are characteristics common to the three examples or the discovery. These are the previous awareness of anomaly. 2 is the gradual and simultaneous emergence of both observational and conceptual recognition. And 3, the concept change of paradigm categories and procedures often accompanied by resistance. Before we proceed to the chapter 13, remember this that not all theories are paradigm theories. Both during pre-paradigm periods and during the crisis that led to a large-scale changes of paradigm, scientists usually develop many speculative and articulated theories that can themselves point the way to discovery. Often, however, the discovery is not quite the one anticipated by the speculative and tentative hypothesis, only as experiment and tentative theory are together articulated too much. Thus, the discovery emerge and theory become a paradigm. So these anomalies were novel in they violated the expectations generated by the current paradigm. Upon further examination and exploration, the anomalies forced the paradigm change and became expected. So the adjustment process involves a shift in the researcher's perspective. Kuhn points out it is not only the case the theory is adjusted when new fact is assimilated, but also this assimilation is incomplete unless the scientist learns to see nature in a different way. So here's Angela Sacdalan to talk about chapter 13.
Moving on to the chapter 13, Progress Through Revolutions. The idea of progress gets rooted in this last chapter. Kuhn is answering the modernist riddle here, trying to figure out whether the sequences of scientific enlightenment and revolution are necessarily driven by progress, or if progress is a side effect of some other process. This ends the book on an open-ended note because the discussion ends up becoming a philosophical treatment of truth, which is just about as hypothetical as it gets, but he answers it at length. Next, in the face of the arguments previously made, why does science progress? How does it progress? And what is the nature of its progress? Here, Kuhn questions what it is that makes a science. Then he comments in an interesting way on what differentiates the branches of science. Thus, he suggests that the strong sense of identity within a scientific discipline occurs when there is agreement within the community on past and present accomplishments. He also writes about the progress that occurred in the arts, as representations became more realistic with refinements in the instruments and techniques of the artist. The relationship between the scientific community and the paradigm is emphasized, as well as the debate that occurs between schools. Kuhn also suggests that although science progresses, it does not necessarily progress towards any specific goal. He also reiterates the effectiveness of scientific revolutions followed by periods of normal science in developing a body of scientific knowledge. However, he leaves the reader to answer the question, what must the world be like for us to know it? Does science progress? It is constantly changing, but does it advance in the ways most people think it does? Kuhn's account of science suggests there is no progress, only change. Yet, progress occurs under a particular paradigm. So, these are the key points or statements that we're going to tackle in this chapter. 1. Perhaps progress is inherent in the definition of science. 2. Does the field make progress because it is a science? Or is it a science because it makes progress? 3. Normal science progresses because the enterprise shares certain salient characteristics. 4. The result or successful creative work is progress. 5. It is only during periods of normal science that progress seems both obvious and assured. 6. In its normal state, a scientific community is immensely efficient. 7. Progress is also a salient feature of extraordinary science. 8. The characteristics of these scientific communities. 9. Though science surely grows in depth, it may not grow in breadth as well. 10. We may have to relinquish the notion, explicit or implicit, that changes of paradigm carry scientists and those who learn from them closer and closer to the truth. Perhaps progress is inherent in the definition of science. To a very great extent, the term science is reserved for fields that do progress in obvious ways. Science makes progress when it discovers regularities in the ways phenomena change over time or finds evidence that supports, rules out, or leads to qualifications of possible explanations of these regularities. This issue of progress as science is of particular import to the social sciences. Is a social science a science because it defines itself as a science in terms of possessing certain characteristics and aims to make progress? Communication across the revolutionary divide is inevitably partial. Consider, for another example, the man who called Copernicus mad because he proclaimed that the earth moved. They were not either just wrong or quite wrong. Part of what they meant by earth was fixed position. Their earth at least could not be moved. Second question. Do economists worry less than educators about whether their field is a science because economists know what a science is? Or is it economics about which they agree? Next, why do not natural scientists or artists worry about the definition of the term? Questions about whether a field or discipline is a science will cease to be a source of concern, not when a definition is found, but when the groups that now doubt their own status achieve consensus about their past and present accomplishment. We tend to see as a science any field in which progress is marked. Progress occurs under a particular paradigm. Indeed, most people tend to see as science any field in which progress is marked. In normal science, practitioners can do their work without first having to evaluate their foundational assumptions and principles. Next is, does a field make progress because it is a science, or is it a science because it makes progress? Science makes progress precisely when it shows the accumulation of scientific knowledge. An episode in science is progressive when at the end of the episode there is more knowledge than at the beginning. Normal science progresses because the enterprise shares certain salient characteristics. Members of a mature scientific community work from a single paradigm or from a closely related set. Very rarely do different scientific communities investigate the same problems. Well, the scientists work from a single paradigm so they don't waste so much time arguing about basic beliefs and methods. So, what does it mean? Common paradigm viewed results to work progress. The result of successful creative work is progress. No creative school recognizes a category of work that is, on one hand, a creative success, but is not on the other, an addition to the collective achievement of the group. Even if we argue that a field does not make progress, that does not mean that an individual school or discipline within that field does not. Example, the man who argues that philosophy has made no progress emphasizes that there are still Aristotelians, not that Aristotelianism has failed to progress. It is only during periods of normal science that progress seems both obvious and assured. In part, this progress is in the eye of the beholder. The absence of competing paradigms that question each other's aims and standards makes the progress of a normal scientific community far easier to see. The acceptance of a paradigm frees the community from the need to constantly re examine its first principles and foundational assumptions. Members of the community can concentrate on the subtlest and most esoteric of the phenomena that concern it. There are no other professional communities in which individual creative work is so exclusively addressed and evaluated by other members of the profession. Other professions are more concerned with lay approbation than are scientists because scientists work only for an audience of colleagues, an audience that shares values and beliefs. A single set of standards can be taken for granted. This insulation of the scientist from society permits the individual scientist to concentrate attention on problems that she has a good reason to believe she will be able to solve. Next is, it is only during periods of normal science that progress seems both obvious and assured. Because during those periods, the scientific community could view the fruits of its work in no other way, in which there's still only a few or no contradiction at all on the works of the people. Unlike in other disciplines, the scientists need not select problems because they urgently need solution and without regard for the tools available to solve them. Note the important contrast here between natural scientists and social scientists. The social scientists tend to defend their choice of a research problem chiefly in terms of the social importance of achieving a solution, while the natural scientists almost never do. Which group would one then expect to solve problems at a more rapid rate? Next, the effects of insulation are intensified by the nature of the scientific community's educational initiation. What are these insulation effects? The insulation of the scientific community from society permits the individual scientist to concentrate in problems that he has good reason to believe he will be able to solve. And it is being said that those who work in orthodox group or with an audience that shares one's own values and beliefs can dispose of one problem and get onto the next more quickly than those who work for a more heterodox group. The educational initiation of scientists is immensely effective. Kuhn argues that science education also contributes to science progress. In other disciplines like philosophy, music, and literature, students read original key texts in their fields and learn that there are competing schools of thought. In science, students don't normally read original texts like Newton or Copernicus. They read brief text summaries of theories and they don't bother studying the obsolete theories. This education is effective but narrow and rigid. It equips scientists well for normal science because they notice when things don't work. However, when a crisis does happen, they're not good at dealing with it because they can create new theories. Scientific training is not well designed to produce the man who will easily discover a fresh approach. In its normal state, the scientific community is an immensely efficient instrument for solving the problems or puzzles that its paradigms define. Progress is the result of solving these problems. We could relate to this what I've said earlier, that normal science progresses because members of a mature scientific community work from a single paradigm or from a closely related set, and because different scientific communities seldom investigate the same problems. Kuhn also took issue with Karl Popper's view of theory testing through falsification. According to Kuhn, it is the incompleteness and imperfection of the existing data theory fit that define the puzzles that characterize normal science. If, as Popper suggested, failure to fit were grounds for theory rejection, all theories would be rejected at all times. Progress is also a salient feature of extraordinary science during a revolution. Revolutions close with total victory for one of the two opposing camps or ideologies. When it repudiates a paradigm, a scientific community simultaneously renounces most of the books and articles in which that rejected or old paradigm has been embodied. The community acknowledges this as progress. In a sense, it may appear that the member of a mature scientific community is the victim of a history rewritten by the powers that be. But recall that the power to select between paradigms resides in the members of the community. The process of scientific revolution is in large part a, de- is in large part a democratic process, a non-cumulative developmental episode in which an older paradigm is replaced in whole or in part by an incompatible new one. And what are the characteristics of these scientific communities who contributes to scientific knowledge? First, the scientists must be concerned to solve problems about the behavior of nature. Second, although the concerns may be global, the problems must be problems of detail. Third, the solutions to problems that satisfy a scientist must satisfy the community. Fourth, no appeals to heads of state, or to the populace at large in matters scientific. Fifth, members of the community are recognized and are the exclusive arbiters of professional achievement because of the following basis. Because of their shared training and experience, members of the community are seen as the sole possessors of the rules of the game. To doubt that they share some basis for evaluation would be to admit the existence of incompatible standards of scientific achievement. Next, the community must see paradigm change as progress. As we had seen, this perception is in important respects self-fulfilling. Next, discomfort with the paradigm takes place only when nature itself first undermines professional security by making prior achievements seem problematic. The community embraces a new paradigm when the new candidate is seen to resolve some outstanding and generally recognized problem that can be met in no other way, or when the new paradigm promises to preserve a relatively large part of the concrete problem-solving ability that has accrued to science through its predecessors. Though science surely grows in depth, it may not grow in breadth as well. When it does, this is manifest through the proliferation of specialties, not in the scope of any single specialty alone. Moving on to the last slide. We may have to relinquish the notion, explicit or implicit, that changes of paradigm carry scientists and those who learn from them closer and closer to the truth. The developmental process described by Kuhn is a process of evolution from primitive beginnings, a process whose successive stages are characterized by an increasingly detailed and refined understanding of nature. This is not a process of evolution toward anything. Important questions arise, such as, must there be a goal set by nature in advance? Does it really help to imagine that there is some one full objective true account of nature? Is the proper measure of scientific achievement the extent to which it brings us closer to an ultimate goal? Next, the analogy that relates the evolution of organisms to the evolution of scientific ideas is nearly perfect. In what circumstances? The resolution of revolution is the selection by conflict within the scientific community of the fittest way to practice future science. The net result of a sequence of such revolutionary selections separated by period of normal research is the wonderfully adapted set of instruments we call modern scientific knowledge. Successive stages in that developmental process are marked by an increase in articulation and specialization. The process occurs without benefit of a set goal and without benefit of any permanent fixed scientific truth. And the last question that we have to ponder about is, what must the world be like in order that man may know it? So that's it. So that concludes our report. Thank you for listening. Take a rest and have a good weekend.